talk about absolute value. We're going to talk about solving absolute value equations today. We're going to talk about solving absolute value inequalities. So those are the two things that we're going to discuss today. When I say the word absolute value, what comes to your mind when we're talking about absolute value? It's a positive number. It's the distance from zero, and those two ideas go together. When you're measuring distance, all right, it's always a positive number. You don't ever say that I drove -5 miles. All right, that's kind of weird saying that. So all of our distances are positive. And so the absolute value is the number of a number x. So we write it like that. We write it with vertical bars, absolute value of x. It's the distance from x to a 0 to 0 on the number line. So we're going to solve this first problem. This first problem is kind of easier to solve. And so if I said x is a number, the absolute value of x is equal to 3, what would you tell me that x could be? -3 and +3. So we're going to have two answers a lot of times when we answer these absolute values. So I have x equals 3 and x equals -3. Those are my two answers. Now, here's the process that I'm going to use to help you solve this, all right? So when we do this, we're going to look and say, okay, is the absolute value by itself on this side? And it is, all right? There's nothing on the outside of the absolute value, so the absolute value is there. The first thing that I would do is I would just take the absolute value and just simply remove it. So if I were to rewrite that problem, removing the absolute value, it would be x equals 3. So it matches that answer that we said, all right? The other one, what we do is we remove the absolute value, so we write x, and we're going to change our answer to be the opposite. We're going to make it negative. And so that's what we'll do. Well, that's the process that we're going to take. We're going to do several examples so we can get better at that, all right? So let's try example number 1 on here, all right? Or A. Is the absolute value by itself here? Okay? Is there anything on the outside of the absolute value? No. All right? So then we would say it is by itself. So on the inside it's okay. We just don't want anything on the outside. So this one is by itself right now. So the first thing I'm going to do is I'm going to take the absolute values off and I'm going to rewrite the problem. So I'm going to write down -3 plus k equals 10. So one of our answers is going to come from that. The other one, I'm going to take the absolute value off. -3 plus k is going to equal 2, and I'm going to change that to a -10. So I take the answer and I make it opposite, make it negative. Now, very identical problems, correct? How do I solve either one of those two? Get the variable by itself by doing what? Adding 3. I'm going to add 3 on this side and that side. I'm going to do the same moves over here. I'm going to add 3 and I'm going to add 3. So k is equal to 10 plus 3, which is 13. And k is going to equal to -10 plus 3, which is -7. Now you notice I didn't find an answer and just make it a negative, right? It's not 13 and -13. It could be, but I'm going to separate them into the two equations and solve both equations, right? So 13 and -7 are my answers. Moving on to question B. Is the absolute value by itself there? This one, the answer to that is no. What do we have to move first? The -6. I have to move the -6 first. How do you move the -6? You add it to both sides. So the absolute value of x over 4, x divided by 4, is equal to -6 or -2 plus 6, which is positive. So that's my first step. Now is the absolute value by itself? Yes. There's stuff on the inside, that's okay, but there's nothing left on the outside. Now is when I'm going to split it into its two equations. X divided by 4 is equal to 4, and x divided by 4 is equal to -4. How do you get the x by itself in this case? Multiply. I'm dividing by 4. What's the opposite of multiplying by 4? Dividing by 4 is multiplying by 4. So multiply by 4 there, multiply by 4 here. So these 4's cancel, so I'm left with x equals 16 and x equals -16. Okay? Now, they are opposites, but I just didn't get one and make it opposite. I solved both equations. Okay? I'd like you to try example C by yourself. What's the first move you're going to make? Add 8, because this is the absolute value by itself? Not yet. So add 8 first. Add 8, add 8. 6, absolute value 6x is equal to 30. Now I got the absolute value by itself, like we've been talking about. Now I write the two equations. Remove the absolute value for one, so that's the easy one to write. The other one is remove the absolute value and make it equal to a negative. All right. Final step is to do what? By doing what? Divide by 6. Yeah. Solve by dividing by 6. So x equals plus or minus 5. You could write it like that if you'd like. All right. You can do positive 5 and then negative 5, or you can do plus or minus 5. I'm okay with that. All right. Now, what I haven't been doing, I haven't been doing a good job of this. So let's go back and refresh. Is it's always good to kind of check your work. Make sure you've done it right. So if I took a 5, plugged it into the original. 6 times 5 is 30. Absolute value of 30 is positive 30. Minus 8 is 22. So that worked out well. If I put the negative 5 in there, 6 times negative 5 is negative 30. Absolute value of negative 30 is positive 30. Minus 8 is 22. So we're good. All right? So let's take a look at the next one. Where would we start on this? Minus 36. So the absolute value is not by itself. So minus 36. So absolute value of 3x is equal to negative 24. I'm going to split it now. So 3x equals negative 24. And 3x equals positive 24. Very similar to this one over here. I'm going to divide by 3. I get x equals plus or minus 8. Check that work for me. Check 8 and see if it's an answer. 8 times 3 is 24. Absolute value 24 is still 24, right? Plus 36 is 60, not 12. So it didn't work here. How about the negative 8? Is that going to make any difference? No, because it's going to be absolute value, which is going to be positive. So these two answers don't work. So no solution. But why? Anybody see anything in this one that would let me know that it's no solution? Look right there. What's absolute value? What answers are absolute value? Positive answers. I have a positive answer equal to negative 24. When can that happen? Doesn't work. Positive answer can't equal to negative 24, so that doesn't work. Go back and look at all the other ones we did previously. What's this? Absolute value is equal to a positive. That was okay. All right. Absolute value equal to a positive. It was okay. Absolute value equal to a positive. So that was the first one that we saw. Absolute value was equal to a negative. So it doesn't work there. That's kind of where this breaks down. All right. So take a look at E. Absolute value equal to a negative. So no solution on this one. Is that true? Not yet. What do I have to do first? I have to get the absolute value by itself first before I make a decision. Can you just distribute? You can't. because I have a negative 1/2. What's on the inside? Well, it could be a negative or it could be a positive, right? So if I have a negative multiplied by a negative, that would make it a positive. But a negative multiplied by a positive would make, so I can't do that there. I have to get rid of this negative 1/2. How do you get rid of negative 1/2? Multiply it by 2. Multiply by the denominator. The denominator is the thing that's bothering me. I don't want to divide by 2. How do you get rid of division by 2? I multiply by 2. Or could you divide by the reciprocal? You could divide and then you end up multiplying. The same thing. What I would probably do is I'd probably multiply by negative 2. Because that negative 2 and that negative 2 are going to cancel, and I'm left with a 1. Which is not anything there. Alright? Multiply by negative 2. Multiply by negative 2. So the absolute value of p minus 2 is equal to 6. Now can I keep going? Yeah. Now I got a positive answer. So finish that one real quick for me. Alright? I'll put the answer up there in a second. So let's finish that one up. So I got p equals 8, and I got p equals negative 4. So I split it, write it down, and then the other one, p minus 2 is equal to a negative 6. Add to both sides. And got it. Questions there? All right, let's do one more of these, and then we're going to go to a little bit different concept. All right? On this one here, how would you start this one? Multiply by 2. It's being divided by 2. I don't like the division by 2. I'm going to multiply by 2. All right? If I multiply by 2, then that gets my absolute value by itself. Absolute value of x minus 5 is equal to 4 times 2, which is 8. Now it turns into an easier problem, I think. Now we can split it. So I have x minus 5 is equal to 8. I have x minus 5 is equal to a negative 8. Add 5 on both sides for both of these. And x is going to equal to 13 and negative 3. Okay? If I wasn't sure, I could take it back and plug it in and check my work. Okay? And so if I'm doing an equation for absolute value, most of the time I'm going to have two answers. Got this answer here and I got this answer here. I got two answers. Okay? Now, when I go talk about inequalities, so that's where we're switching to. We're going to go talk about absolute value inequalities. All right? So if I was going to do that, when I do an inequality, I'm going to do the same work that I'm doing, except now I have more than just one and two answers. All right? I've got a range of numbers that work. Now, before we get going, there's a real important rule with inequalities that we have to remember. Anybody remember their important rule with inequalities that we have to be mindful of? When you multiply or divide by a negative number, that's correct, by a negative number, multiply or divide by a negative number, we have to flip the symbol. What I'm talking about that less than or that greater than. When I multiply or divide by a negative, I have to flip the less than, make it greater than, or vice versa. Do you have to do that with an equation?
No.
What happens if you flip an equation or equal sign? It looks the same, right? It doesn't look like it's changed. So technically you could say we're still flipping it, but it doesn't change. But inequalities, they do. All right? Now, when we were talking about inequalities of absolute value, an absolute value creates a compound inequality. What is a compound word?
Two sentences put together.
You're thinking compound sentence,
Oh.
alright, which is good too. A compound sentence is two sentences that are put together with like a conjunction. Like this and this or whatever, or but, or whatever. Alright, what about a compound word? Two smaller words put together for a big word, right? What is an example of a compound word?
Can't, whatever. Ain't.
That's a contraction.
I don't know. Oh.
Swimming.
Watermelon would be a compound word. We got water, we have melon, we put them together. Watermelon's a compound word. Doghouse. Dog and house. What'd you say?
Light bulb.
Light bulb would be one. Light and bulb, light bulb would be a compound word. So we're taking two smaller things, put it together. You're going, this is math class, where we're talking about compound words, right? So, because a compound inequality is two or more smaller, two or more inequalities. Can't spell, let me try that again, right? Two or more inequalities put together. Most of the time it's just going to be two, all right? You could have more than that, but with the compound inequality, we're going to take at least two inequalities, two smaller inequalities, we're going to put them together for our compound inequality, okay? There are two types of compound inequalities, all right? There's two types of compound inequalities. The first type of compound inequality is a disjunction. What's the prefix dis mean? Like disrespect, what would disrespect mean? Not respect. What does dislike mean? Not to like, all right? So a disjunction means what? Not junctioning. It's not coming together, all right? So a disjunction is not coming together. Yep, we can go back there too. All right? So a disjunction is not coming together. The picture of that would be an inequality that's moving to the right and an inequality that's moving to the left. Those two things are not coming together. They're going in opposite directions. Okay? The key word that we use with disjunction is the word or. Okay? Or is the key word for disjunction. We could be less than this number, or we could be greater than this other number. All right? So we could be on this side, or we could be on this side. So as long as I'm one or the other, I'm good. Okay? Here's an example of a disjunction that's graph forming. We want to write the answers to this. Okay? Two different ways that we can write the answer. We can write them in inequality form, which are going to have their less than or greater than symbols in them. Or we can write them in interval notation. I think we've talked a little bit about interval notation. We're going to discuss some more. What is the key number on this side over here? -3. -3 is the key number. How does everything compare to -3? It's less than or equal to, because it's colored in. So we'd say x is less than or equal to -3, or, because it could be that side or this side, or what? X is greater than 2. Okay? X is less than or equal to -3, or x is greater than 2. Now, if we talk about interval notation, we're going to get the big number and the small number in each region. What is the smallest number if I'm going that way to the left? -8, that's shown, but it keeps on going, right? -infinity. -infinity, and then the big number in that region is -3. -3 is going to get a bracket. When do I use a bracket? I use a bracket when it's equal to, because the equal to sign, if you were to connect an equal to sign, it creates a bracket. So anytime that I'm using an equal to, it's going to have a bracket. If it's not equal to, it would have a parenthesis. I could be this interval, or I could be 2 is the smallest number. What is the biggest number on that spot? Positive infinity. Okay? So this is inequality notation, that's interval notation. All right? If it is a free response question, do I care which one you write it in? Not unless it tells me, okay? On a multiple choice, if they write it a multiple choice and they have it written in one or the other, you have to understand it enough to know which one to select, okay? They won't both be given. All right, let's go to the next one. So that's a disjunction, the word or for it, all right? Conjunction. What does conjunction mean? That they're coming together, all right? And so on this one, conjunction means is coming together. All right? Yeah, you can sing that song. You got all those conjunctions, and, but, or, all those things that come together. All right? And so here's what's taking place. We have a inequality that's going this way. We have another inequality that's going this way. And what we want is we want where they're coming together. So if I were to overlay the red and the green, it would make this in-between part right there. That would be my conjunction. All right? The key word here is the word and. So what numbers are on the red one and on the green one? What numbers are on the red one and the green one? It's where they come together. It's where they cross. So it would be all the numbers on the blue one is what are shared on the red and the green. Okay? Now, the inequality here. What are the two values here that are important? -3 and +2 again. The interval notation I think is probably easier to write in this case. The smallest number is -3. The biggest number is +2. Because the -3 is colored in, it's going to get a bracket. Because the 2 is not colored in, I'm not equal to it, it gets a parenthesis. I'm done. All right, so that one's pretty easy there. Now, if I'm going to write the inequality notation for this one, I'm going to be less than 2, and I'm going to be greater than or equal to -3. That's where you hear the word and in there. Less than 2 and greater than or equal to -3. So that's how I would write that in inequality notation. Okay? Everybody good so far? All right, so we're going to start kind of basic like we did a while ago. At the bottom of the page, you have this right here. You have x is less than 3. The absolute value of x is less than 3. You have the absolute value of x is greater than 3. Okay? Now, let me give this to you with as you're going. All right? We've been talking about prefixes and compound words and stuff like that, all these English things. All right? Now I'm going to do something that your English teacher is not going to like, so don't tell them about this. All right? What is this symbol right here? It's a greater symbol. All right? If you're from Texas, greater. Greater. All right? I'm going to spell greater like that. I'm going to spell it greater. All right? Because anytime you have a greater than symbol, you hear the word or in there, greater or, right? Especially from Texas, greater, all right? So this graph right here should look like a disjunction. It should be going this way, and it should be going this way. So when I do this one, I should have a disjunction. It's a great or, then I'm having a disjunction. Sometimes when you're in Texas, you hear people talk so fast that they don't enunciate or they just say all the consonants. What's this one right here? That's less and. All right, that's less and. All right, so less. It's less and. All right. And so this one right here is going to create a conjunction. Okay. Now I'm using this. This is very helpful for me. So to know if I'm getting the correct graph or not, okay? I know it's silly, all right? Sometimes I talk like this, I try not to, all right? But that's the case. Now, let's work these problems. Is the absolute value by itself on this one? Yes. So what did we do a while ago? We took the absolute value off and just rewrote it, okay? The other thing that we did is we took the absolute value off and we made it a negative, correct? Well, what do we say if we use a negative? What happens? We're going to flip the sign. We're going to flip that symbol. So I'm going to go graph this. So the two numbers that are important here are positive 3 and negative 3. Again, put the numbers correctly on my number line. The negatives are on the left, the positives are on the right. I want to graph x is less than 3. So x is less than 3 this way. X is greater than negative 3 this way. And if you look, those two things look like they are coming together. Correct?
Correct.
So this is a conjunction graph, and the green is my answer here. All right? It is a less and. All right? So they're coming together. That's what my graph would look like. Okay? Now, over here, if I were to do this one, x is greater than 3, and x is less than negative 3. Again, if I were to draw this, 3 and negative 3 are my important numbers on this graph. X is greater than 3, so I'm here. X is less than negative 3, so I'm there. So it has created a disjunction graph. All right? Good. Now, how many answers on here? There's a lot of answers, correct?
Correct.
Everything that's shaded here is an answer. Everything that's shaded in the green is an answer. So it's not just two answers. It bounds to certain regions, and we get these answers. So let's turn the page. We're going to do a couple more examples, and we'll be done for the day. All right, here we go. Let's take a look at this one. All right. Is the absolute value by itself on this one? Yes. I'm okay with things on the inside, just not things on the outside. So I'm good. So before I split it, what symbol do you see? Great or, right? All right, it's a great or. So what should my graph look like? Should be a disjunction. They should be going apart. That's what I should get. So let's take a look. I'm going to write it down. Negative 4q plus 2 greater than or equal to 10. So there's one of them. Negative 4q plus 2 is less than or equal to negative 10. So I split it. I had the absolute value by itself. I took the absolute value off and I rewrote it. Then I took the absolute value off and I flipped the symbol and I made it a negative. Everybody okay with what I have up there?
Yes.
All right. Now what? What am I going to do next? Solve for q by doing what first? Minus 2 on both sides. Good? So if I do that, I've got negative 4q is greater than or equal to 8. And negative 4q is less than or equal to negative 12. Now I'm going to divide by what? The negative 4 in front of the q. Now, what's interesting about this? What happens when I divide by negative? I'm going to flip the sign. So this would be q is less than or equal to negative 2. And q is greater than or equal to positive 3. Because this was a great or, because it's a disjunction, I put an or in between both of those, and that is my solution. So my solution is q is less than or equal to negative 2, or q is greater than or equal to 3. Now it says graph, so I'm going to go build my graph. So if I build my graph, the two numbers that are important, negative 2 and positive 3. I'm going to shade less than negative 2, which is which direction?
Left.
To the left. I'm going to color that in because it's equal to. So I have that there. I'm going to shade right because it's greater than. All right. I'm going to color it in because it's equal to. Is that an OR graph? Yes. So I feel like I've done this well. All right. So it looks good. There's my graph. Here's my solution. Could I write this in interval notation as well? Yeah, the small number is negative infinity, the big number will be -2, or the small number is 3, that would be a bracket, and the big number is infinity. So I could write it like that also. Okay? Now again, it's for your response, you could write it either way if it's multiple choice. If they've got it written in interval notation, you need to be able to pick that out. Okay? All right. Next. We good?
Yeah.
Okay. What's the first thing I need to do? Add the 4, because it is the absolute value by itself. Not yet. Okay, so I'm going to add the 4. So add the 4 and add the 4. So absolute value of 4x minus 8 is less than 12.
Now you gotta do the 8, -8.
Okay, now before I do that, what am I going to do? What's the symbol? Less than. Less than. So what does that graph should look like?
Wait, now, hold on.
It should be a conjunction. They should be going together. All right? So I just got that in the back of my mind. So when I finish this, that's what it'll look like. Now I'm going to split them. So I got 4x minus 8 is less than 12. And 4x minus 8 is what? More than -12. So flip the symbol, change the sign. Okay? I'd like you to go finish that real quick. All right. So we split it. I added 8 to both sides. So I got 4x is less than 20. I got 4x is greater than -4. I divided by 4. So I got x is less than 5 and x is greater than -1. So where I'm at right now, I've taken these two values and I put them on my graph. All right. Where is x less than 5 at? To the left. So I'm moving to the left. Where is x greater than -1? To the right. We said this was an and. So what should be important about that? They should be coming together. So my answer is that piece right there. All right? So it's where they cross, where they come together. So from -1 to 5. If I write the solution, it's -1 to 5. That's interval notation. Some of you are going, that looks like a point. Yes, it does kind of look like a point. But the parenthesis means I'm not equal to. Or you could say that x is less than 5 and x is greater than -1. That's how I'd write the conjunction. The weird thing about the conjunction, I like the disjunction because I can put an or in the middle of this. I can't just throw an and in the middle of that and say, there's my answer. It doesn't work like that. All right? I've got to put them together. I got to put the x in the middle because the x is between 5 and -1. Okay? All right. Let's handle one last one. We'll be done for the day. This is our last one for the day. All right? So I'm going to let you get started on that. I'm going to catch back up. I'll put it up there and see how far you can get through the problem. You need to do a few steps. But the fact that you notice there's something weird about it. There is something weird about it. We'll talk about it.
Plus
You're in the
24,
track.
but I'm not ready.
Are you finished?
Yeah, I think.
Did you draw your graph?
But is that right? Divide by 3. Divide by 3.
Alright. Where do we start on this one? Is the absolute value by itself? Not to start. So I move this, alright? As I was walking around, somebody, a couple people said, something's up here. I'm gonna keep going. I'm gonna come back to this here in a second. So I have this. By the way, what's the symbol? Great or, alright? It's great or. So what should this graph look like? Should go on away from each other. It should be going outward, alright? So that's what should happen. So I'm gonna finish solving. 3x is greater than negative 24. Took the absolute value off. 3x is less than negative 24. It's a pretty easy one to solve because I'm going to divide by 3 on both sides. So x is greater than negative 8. X is less than, I forgot to put a positive there, sorry. Flip the sign and make it positive. So that's positive. Okay? Everybody okay with what I have so far? I'm going to put that on my number line. Alright? So if I were to do this, the two values that are important, 8 and negative 8. How am I shading versus negative 8? I'm going inward. I'm going this way. Alright? How am I shading for positive 8? I'm going that way. Alright? Now, this junction, what's the key word? Or. Key word is or. So I can be this or this. So my answers can be anywhere. As long as I shade it, alright, then the answer is true for an or. Alright? Well, what did I shade up here on this graph? It looks like an and, it looks like a conjunction. So I know something's wrong here, or something's up. But how much gets shaded on this graph? 100% got shaded, correct? Everything got shaded. And if it's an or graph, I don't need to know where they cross. I just need to know what's shaded. All real numbers is my answer for this one. Okay? Now, let me go back. Look at this. A couple people acknowledged this when I was walking around. What is this? Absolute value. By the way, what type of number is an absolute value? Positive. A positive number is greater than a negative 24.
Yes.
That's always true, correct? Positive number is greater than negative 24. It doesn't matter what you put in there. It's going to work. That's all real numbers. Now, a while ago, we said a positive number is equal to a negative number. Is a positive number equal to a negative number? That was the no solution a while ago. Now, one last thing on this one before I finish. What if I did this? What if I took this whole problem and I made it this right here? Okay? What's this now? It's less than. And so it should be a conjunction. They should be going together. Well, automatically you look at it, hopefully, and you say, well, I have a positive number less than a negative number. Can that be true? No. So this is no solution. What would happen in this case is I'd still have the 8 and I'd still have the negative 8, but I would be shaded here and I would be shaded here. But this is a less than. This is an and. Should be a conjunction. Is this a conjunction? Is there any spot that there's overlapping? No. So that would be a no solution. All right? Make sense?
Yes.
Now, that's kind of weird. It's kind of different. Here's what I'd like for you to do. We've got about 2 minutes left. All right? Tomorrow, in class, you're doing the first page on your assignment. It's 1 through 8 and 1 through 8. That's what you're doing in class while I'm gone. I will stamp that on Thursday when we get back. So if you don't finish in class, then you're doing that for homework. Okay?
I won't be here Thursday.
Okay.